Thank you very much. Good afternoon to all of you. First of all, let me thank Dr. Raji for inviting me and making it happen, because her perseverance was so good that I couldn't say no finally, and I had to make it. And also, she only suggested, why can't you talk about the evolution of our launch capability and what are our future directions? And I have tailored it accordingly. I hope I should be able to finish in 15-20 minutes. I also heard in the morning the debate and discussions on various things. Creating the space assets, whether it's for civil or defense applications, the launch capabilities, we have to really tailor it to meet these demands. But in India, what has happened is that all along, all our launch capabilities are well tailored with the civilian applications, but not defense. I think a lot more has to be done in this area. I think some kind of integration has to happen, the capability with respect to the defense, how we are going to do that. And I also heard on the space command and things like that. But then I think something has to happen, and it has to happen from the top. The directive has to come today. There is some kind of barrier between the civilian applications and defense for reasons known to them. But that's how we are not able to go further. Can I have the next? Look, basically what I mentioned, the civilian application, I think it's well known. I don't want to get into that. But then really our applications building the spacecraft or trying to build the launch capability, we have tailored to the requirement given to us as the space department. That's what we have done. And there is certain work going on in the defense area also, but then somehow I not put it because generally we don't project it in this kind of forums. See, what we have done is the space program, I think all of you know that it's nothing new. Depending on the requirement, basically it's application driven. When I say civil application, all application driven, and in order to meet those applications, we are building our own payloads and spacecraft meeting all the demands. But then what is more important is to develop the launch capability, and I'm going to concentrate more on that really. Of course, the capability exists. Whether you want it, the remote sensing or communications or any, I have just now heard that we have been operating only in certain orbits. That's because the requirements are given like that in terms of communications, remote sensing, and scientific experiments. But then if there are requirements to have it at any different inclination, different orbit, I think it's possible for us to really go ahead and do it. Question is again, how are you going to really integrate it? Of course, this is the real evolution which has happened, and I don't want to dwell too long for here, accepting that the first two, whatever you are saying, that they are the learning curves. In fact, that's where we master the technologies, the different technologies. One interesting thing is that system integration, system engineering is very complex when it comes to the developing the launch vehicles. That's one reason people often keep talking rocket science. That's what it means. And then, I have authored a book along with the present chairman, Dr. Shivan, on integrated design of space transportation system. How complex it is, I think if any of you are interested, you can just go there and look at it. How we are able to bring in together the different disciplines of technologies in terms of materials, in terms of propulsion, in terms of aerodynamics, and whatever related. If we are not able to do that, to tell you frankly that the European program, I think what they started way back in the 1950s called ELDO program, they had about 6 or 8 countries they joined together. And then they had 11 launches, all the 11 launches failed. Then only I think France took the lead and then became the key operator as a system engineer. I think many of you may know that, started the Diamond program and then Ariane program, and it succeeded. And what you see, the third and fourth, they are the real workhorses. I think many of you know that the Polar Satellite Launch Vehicle today has become a workhorse, and then we have been sort of recording success after success, excepting one lost launch, one before that. I think we got into problem for some small little problem somewhere in the quality related matters. Otherwise, This we are able to really take care of the entire requirements of multi-capability, multi-operations, multi-missions, and as well as in one launch, I think many of you may be aware, 104 satellites we launched. It's belonging to several other countries, and today it is no big deal. When you are having the small spacecraft required for any purposes, we have the capability, and we can put much more and then launch it, not just in one orbit, we can even launch it in different orbits. Because now we have the capability to restart the terminal stage and then take it to a different orbit. In fact, in the last 2 missions, we have done that to have the first burn, second burn, third burn, and try to achieve to take it to different orbits. Because depending on the satellites that you need for a different application, we can do that. And of course, the geosynchronous launch vehicle, basically, as the name suggests, it is essentially required to put the communication satellites. And we have, as on today, remote sensing, I think we are totally self-sufficient. But when it comes to the communications, we still lack to carry that capability. In fact, we are working on that. That's what the last one, what you see, GSLV Mark III, which weighs around 630 tons at the takeoff, can take up to 4-ton satellite into communication orbit. So that is what is required. Right now, because we don't have the capability, we go for a procured launch and then go ahead with the requirement. Of course, this is just to say that how difficult it is. The entire thing happens. The people who are not aware, I would like to mention here that whole thing is about 17 to 20 minutes, but then the operations are thousands of operations, and you can see how much it traverses in that 20 minutes, almost 7,000 kilometers it goes and then puts the spacecraft on the other side of the globe, just to give you the complexity of that. See, what is more important is while we have done, we have taken care that progressively the technologies have been improved. The essence of the whole success depends on how well you are able to conceive the technologies and take it forward. And for want of time, I will not dwell it, but then that is done in a very systematic fashion. How the technologies have to be improved in terms of propulsion, in terms of avionics, in terms of control, in terms of enhancing the capability, increasing the energy that you need to carry the payload into the orbit. That is what has happened over a period. This all demands developing the appropriate engines, appropriate the stages, then trying to minimize the weight, upper stage weights, go for a very complicated technologies like composite materials, carbon material, a host of things. I think any one change you do, the qualification that is required for you to say that it is flight worthy takes considerable time. There is a demand on that. Now, while we do on the launch capability, at some point we also attempted to bring back, put it in the orbit. This is one flight, one of the PSLV flights, where we took a module to a certain altitude. Of course, we also combined in this the remote sensing spacecraft. You can see here, this is the remote sensing space Cartosat, and then this was the module. I put a star there. What we did is, first the polar orbit, we put the Cartosat into its orbit, but then we brought down the orbit to a different orbit. From there, we sort of completely deorbited and then brought back, and then we got back the module at 120 kilometers east of Bay of Bengal from Sriharikota, procured it, and then today we can say that the difficulty involved is it comes through very dense atmosphere, which means you have to, it should withstand the temperature around 2,500 to 3,000 degrees Celsius, and still whatever is inside is capable of really sustaining the vigor of the temperature. That's very important, and this is needed because in the long run you want to bring back the men or material or cargo. It's possible. I think this capability exists, and we did one more as we go along. I will tell you. Of course, at the same time, we are conscious of bringing down the cost. Today, all over the globe, you look at it, the launch cost, what really costs per kg putting into the orbit is more important. It's anywhere between 15,000 to 20,000 US dollars, wherever you go, excepting, I think, the recent SpaceX of Elon Musk, the recovery what he has done and in the able to recover the cost, amortize the cost. I think he is trying to bring down the cost. That's why recovery becomes very important. This is one experiment we did some time back last year, Of course, we put a module with the winged aircraft and then marrying the rocket technology and the aircraft technology, and we sort of put it into the orbit, and from there again it has come back, and then landing we didn't try because landing is not a big deal in a country with the kind of aircraft that are available. What we did is we just brought it, and then we also didn't recover, but the whole operation has gone very smooth. The thermal requirements and these things we have seen very carefully. The idea is that if we are able to succeed, then I think we'll be able to bring down the cost. And if we have to stay in the business of putting any amount of satellite, or cost has to be brought down. Of course, it has many other civilian applications which is of national interest. This is the one important vehicle which we launched twice. Sometime back in the end of December we launched, and then we did not have the cryogenic stage because that is a very vital. We go for a different propulsion systems which gives the higher energy for the same mass. That is the whole philosophy behind increasing the energy so that your mass comes down, you are able to put maximum payload into the orbit. That's how we are looking at it. And in this you can see the number of stages also we have reduced, and we have put a higher power cryogenic stage, is almost 20 tons thrust and 25 ton loading. But the question is that it took some time for us to really prove it. But then the entire vehicle as an experimental mission, we did it in December 2014. And then the whole technology that is required in terms of propulsion system, the separation, atmospheric phase flight, all those things were done. But what is interesting is while we do that, it went up to something like 110 kilometers altitude, and we put what is required for the human space mission, crew module we call, where the crew can stay 1:1. We took it to 110 kilometers. Then from there it separated, and then it has come back and then landed in the sea actually. So that is one experiment where we done all instrumented and able to visualize what really happens when we get the humans from space back to Earth. That is the whole idea. And of course, from here onwards, I am going to give you what are the future thinking. The question is that I also heard that capability to meet the higher payloads, whether we are geared up. You see, we are geared up. Question is that we need to get the needed clearances by the agencies, by the government, to say that this is the direction that you need to go. As far as the capability is concerned, I can tell you that today we have the needed capability. And what we are trying to do in this is same what I showed earlier. Mark 3, whatever I shown, you can see that the semi-cryogenics, so this is what you see here. From the earth storable to we are going to semi-cryogenics. So that once you go, you are able to enhance the capability. What otherwise is 4 ton today, we I think move on to something like a 5 ton, and this development is going on, and you don't change anything in the vehicle. Your outside dimensions, your aerodynamic structure, all configurations are kept intact, but then you are able to really meet the demand of higher payload. You see, the question is that all over the globe, particularly for defense applications, your satellite is very small. You don't require a big satellite. It can be as small because of the kind of electronics improvement, avionics improvement that have happened in the globe today. You can shrink it to a very small size. I think as somebody said rightly, in our own PSLV, we are supporting many such satellites which are launched, but they use it for their own applications. And in order to meet this demand, we have seen that tremendous amount of requirement has come for the small satellite. And in order to launch that using PSLV, it's a big affair. You have to really spend so much money, integration, time, everything is involved. So what we have done is we have gone with a very, very tiny pencil-like vehicle. This is configured with all solid, no liquid is there, excepting that you are able to have a terminal liquid stage to cut off the velocity when you want. We have done that. The advantage is you can launch it anytime, the cost will be low, and you can launch as many at any given point of time. This is what ISRO is embarking on, and this is expected to be launched very soon. Of course, now about the heavy launch vehicles, I want to really dwell on another 4 or 5 minutes on how we are really going ahead, taking the modules which are already developed, how are you going to cluster and then enhance the capability. You can see here that the first one, what you see here, without any strap on, it can really take about 5 tons to communication orbit and about 10 tons in the lower Earth orbit. And by just adding the strap-ons, we can enhance the capability to 8 tons and then also 18 tons to LEO. Again, the question that we need to answer is there a need to have enhanced capability in the spacecraft? Because while the avionics has shrunk and come down, the satellite capability also has come down all over the globe. I think one has to keep in mind, and we are debating on that, how to really go forward and take it forward. And another important thing I would like to mention is that, we would like to achieve zero defect. For the simple reason, why the launch vehicle face so much hostility, because the very high reliability and enhancing the zero defect is extremely important. And unless you do that, we are not going to go anywhere. So in order to do that, you take what we call pedigree, the proven stages, well tested to the extent possible. You cannot go on developing a newer propulsion-based systems for purpose of launching the spacecraft. It has to be based on the modules that are available, how well you are able to integrate, how well you are able to take it forward. That is the direction with which one should work it. And also the configurations. You can't go on changing the configuration for the simple reason you just add one small element on the external surface, your whole the dynamics changes in terms of aerodynamics, in terms of many other related issues. So that's why you have to worry about that. Now, future heavy vehicles, in fact, they are all rated for very high, for example, you can see in the center, it can take even up to 15 tons to low Earth orbit. We have done that. And I told you that the aircraft configuration which you have flown, it was an experimental venture. But then now we have come out with a configuration where you have a rocket. On that you mount this recoverable stage. Why aircraft means after the separation, it goes about 80-100 kilometers. After that it comes back just like an aircraft and lands. This experiment was done, but basically it has not really progressed for the simple reason. The thermal insulation that you need to do is the most complex. The one that is available is all, tiles, and it's a very cumbersome process. I think we are on the job to come out with the solutions to that. It's all over the world, it is same story actually. So these are the 3 important things that we are working on that, which are really required as a future vehicle. You see, this is how we are going to do that. The one which is on the top on the aircraft on your right, you see, it will be separated, then it will come back just like an aircraft and then land at some known point. Of course, we are trying to bring some kind of landing in Sriharikota. It's just there. And the one which is there from the orbit, you deorbit, guide it, bring it. This is precisely what we did for space recovery experiment, which I told you some time back. The technology remains one and the same. You just bring it back so that both of them you refurbish, you sort of again see whether it's capable of going through the further test, and if you are able to do that, cost will come down. These are some of the things that we are trying and then working on that. And it wouldn't be proper if I don't mention about the human space program. In fact, technologies that are needed for that are all available today. A lot of development has gone. Only we need the clearance by government. In fact, government is actively considering, and as and when it happens, I think we are ready. In fact, I told you that we have done a couple of experiments. That crew module, we brought it back some time back. And also the one that what you see on top here, that is where in case of any eventuality, the humans who are inside should be brought back safe. It's called something like ejection system, just like what happens in the fighter aircraft, the person is ejected, and although aircraft gets into the difficulty, the person is saved. So the similar kind of thing as it goes from the launch till the satellite injection, anywhere it happens. For that, in fact, we have tried out certain tests, and then one of the flight tests is expected very soon. It should have happened last year, but I think because of the other priorities, they kept it pending. Now that will happen. So the question is that we are really trying to, this has where the crew can stay, the life support system, all other technologies which are there. One can talk for hours, but then all of them are developed, and I think the next one, what is there? It shows that the kind of technologies that are required. I don't think it's appropriate to get into that, but then each one of them has been developed either by ourselves or with industry or with academia. When I say that all these programs, it's just not ISRO. I think it is the collaboration with the entire the industries that are available in the country, and today they are geared up and they are coming in a big way, and also the academia where we really consult, get the necessary input. So they are all our partners, and then we keep moving. So that's how it is. And also I would like to stop here by mentioning that, it's very heartening to see that today there are a number of startups coming from the youngsters. It has picked up the space arena where the youngsters have shown a lot of interest. It's very difficult process, very expensive, and again safety is involved, security is involved. But in spite of that, very many youngsters, they have come out with the bright idea, and I see some of them here in the audience. It's very nice to see these youngsters really looking at taking the space arena to elsewhere. I don't think one can really say that we will be able to meet the country's demand down the line from now to 20, 25 years in terms of civil, in terms of defense, which has to happen, in terms of command, that whatever you are discussing. And that is where I think we need to have very many, the organizations, private, public, all coming. And it's very heartening to see that youngsters are taking the lead. And then I wish them all the very best. And it's getting evolved. I think it's only a matter of time that things will happen over a period. Today there are certain restrictions, but then I think we have to come out of that. So two things. One is that this is the time, I think particularly for this forum, how we can really integrate the defense and civilian needs, particularly launch vehicle. I don't think it's proper for launch vehicle, the defense people to develop one more set of launch vehicle. Reinventing the wheel will not take us anywhere. So it's extremely important how well we integrate. This has to happen right from the top, and then there is a need to put our efforts together. And second is to encourage more and more youngsters to venture in these difficult areas. They have the capability and we have the experience. We are able to put these two together. I am sure the country will go miles. Thank you very much.
Thank you very much, sir. Roger, we have a few moments for questions.
Yeah, this time.
Fantastic. However, I am going to use my own prerogative as moderator to ask the first question, and then I will open up to the floor. Sir, the world is very much impressed with India's success record in launches. But the thing that I think everyone is most impressed by is that India is able to do it at a fraction of the cost of any of the other competitors. What do you think is the reason for India being able to do this?
There are two things. One is what we term as the risk management. I think you may be aware in any such management how we are able to sort of take the risk. In other words, I can give you just one example. You take the booster stage of what we use in launch vehicle. That is roughly, today it is about 125 tons solid propellant it burns and about 2.8 meter diameter. All over the globe, its equivalent is there in space shuttle program, equivalent is there in the Ariane program. In order to qualify that particular stage, they have gone through something like 8 to 10 different ground tests before they can clear it for launch. This thing holds good with many other hardware. Whereas we have really spent a lot of time in understanding what is involved in terms of materials, in terms of propulsion technology. Mind you that we just did only 2 tests before we cleared for launch. Each such one test, for example, to test on ground, it costs anywhere between 15 to 20 crores for us. Like that we have done in several areas. That is number one. Second thing is, the labor cost in India and also manufacturing cost compared to any other countries, it is much better. So there are such compounding factors, and I would say more that the way in which you are configured, the way in which you are having our test philosophy and then qualification programs, I think that has given big way to reduce the cost.
And the success rate is certainly a testament to the effectiveness.
Yes.
So I open up the floor. Marco clearly has a question.
Thank you very much for this very informative presentation. My question was whether ISRO has any plans for micro launchers, and if yes, where demands come from like the defense community, the academia, or like the commercial. And another one, actually, sorry, I apologize, I have like too many. Will GSLV will be commercialized, and if yes, will be also privatized in the future, from a long-term perspective? In
both, the first one was on microsatellite?
Yeah.
Yeah,
micro launchers, sorry, micro launchers.
Yeah, that's what I mentioned, that we are working on that. The immediate one is how can we really bring a launch vehicle which can launch small satellite. That's one effort that we have put, and I'm sure it will happen very soon. And as far as the commercialization is concerned, I think my friend is here, Shivdhana Pillai. He really helped us to put things together. That can happen only we are able to totally go to industry. I think the production we should not be handling as an organization. Today we have been handling, and it's really affecting our futuristic programs. But I think like Ariane program, they went to Ariane space, and then totally industry takes over. All over the globe is like that. And Indian industries have matured today in the country, and they are capable of taking it and do end-to-end integration. But for certain time, hand-holding is required. That's what we are trying to do. And I would say from now to another 4 or 5 years down the line, already every hardware is done through industry only. We don't do anything. But then the system integration, putting them together like Ariane Space does, that's what we are looking for. And I think industries are taking a lot of interest. And the first concept could be go on the consortium mode, so that try to put them together, one taking the lead and others trying to help. It's all going to happen. Mind you that maybe another 3 or 4 years down the line, this will happen.
Other questions before I continue using my prerogative?
So regarding the SSLV that we are developing for the small satellites, can't we, is ISRO planning to take an approach where they develop and integrate the vehicle themselves and then transfer it to the industry, or will the vehicle directly be something that will be industry accessible and be something that is commercial from the start?
Look, I think still, like I gave an example of ELDO system, looking it as a system that requires the full knowledge of the entire technologies in terms of how well we are able to understand as a system, in terms of propulsion, in terms of aerodynamics, in terms of configuration, and these mechanisms, many things which are there. So we don't want to, after these many years, get into a problem right at this point and then try to experiment on something else. I think it will take quite some time. Our approach is first we will do it, we will launch it, and make sure that we will be successful. I am very sure it's not a big deal for us to do that, and then trying to hand over to the industry. But if you bring right in the beginning, I'm afraid we may not be able to really do the justice. Thank you.
Raji, do we have time for another question? Okay, very short question, please.
Yeah, my question is basically on the Spaces 2.0. There are many articles written on, the new spaces. Do you think India is a part of that race, or could be a part of that race? And secondly, if yes, this race and cooperation with the major powers who are, major powers in the space sector, can that go hand in hand?
Yeah, if you really look at it, that's where I was representing he mentioned that UN COPOS, where all countries, 135 countries, they join together, look at each other and see how the cooperation can be done. I think the whole globe is really marching towards having the cooperation in many, many areas. That's where this problem of, not able to mix with civil and defense, the issue has come only because of that. When it comes to the defense, nobody would like to cooperate with anyone. It has to be done on your own. But when it comes to civil, yes, we can have. That's why this difference of civil and military has come all over the globe. And today we are also having lots and lots of collaboration wherever possible. But the question is, because of capability can be used for defense purposes, we are always under embargo, I tell you. Today when we launch PSLV or GSLV, it is 100% indigenous. For the simple reason, we are not able to get anything from anyone actually. It is so also with our friends in DRDO who develop the missiles. We are just under embargo, we are not able to get anything. Only on some kind of the soft technologies and other things we can collaborate or get it cross-checked. Otherwise, we are in that situation. Not only us, I think all over the globe is like that. Thank you.
And if I may add my own 2 cents to that, I think, sir, you've really driven this home, but the main message that I've been getting from this conference so far is that when it comes to outer space, India is not messing around. They are a power in space and will continue to be so. So on that note, please join me in thanking Mr. Suresh and wishing him a good journey. Thank you, sir.